Okay, so for the last subtopic, okay, we will look into refraction, okay, through thin lenses. Okay, so for example 7.7, okay, you have a person. Okay, so over here height given as 1.75 meter. This will be the height of the object. Okay, standing 2.5 meter in front of the camera. So this one will be your object distance, okay, U. The camera uses a thin biconvex lens, okay, and then the radius of the curvature is given as 7.69 mm. Okay, so for the shape you can refer back at the diagram. Okay, we have a biconvex. Okay, so that means it will have a convex surface on both sides. Okay, and then the lens is made from a crown glass. Okay, where the refractive index is given as 1.52. Okay, so they want you to calculate the focal length, okay, of the lens, and then B, sketch a label diagram to show the formation of image, and then C, determine the position and height and its height, okay, of the image, and then the characteristic. Okay, now the information given, okay, we have height of object, okay, HO 1.75 meter. Then object distance U 2.5, okay, from the question. Okay, refractive index of the medium glass. Okay, since now we have a biconvex lens, okay, the first radius will be positive. Okay, so if you look at the biconvex, okay, so the shape will be like this. It will be convex on both sides. Okay, so let's say if you have a light ray traveling, so this will be the R1, okay, radius 1, which will be located at the convex surface, okay, which will be positive value lah. Okay, and then over here R2, okay, which will be a concave surface, so that means you will have a negative value over here lah. Okay, R2. Okay, now once we have all the variable, we can replace into the lens maker equation, okay, where 1 over f will be equivalent to n minus 1 over r1 over minus 1 over r2. Okay, so just replace in the value. Okay, so replace in the value, so which will end up with focal length 7.39 meter. Okay, so that means positive focal length. Okay, so basically for a convex lens you will get a positive focal length. Okay, real focal length. Okay, and then B, they wanted to sketch. Okay, so for this part, okay, your U is greater than 2F. Okay, because F over here is given as 7.39, okay, where U will be more than twice the value lah, which is 2.5 meter, right? Okay, so that means for the characteristic, okay, one straight line parallel with the plane, okay, refracted toward F, okay, another one through the optical axis, okay, which will be a straight line. Okay, so it will intersect between F and 2F lah. So where you'll have an image formed over here. Okay, so the characteristic later we will discuss through. Okay, see the position. Okay, so since we have the focal length, okay, object distance, we can find the image distance. Okay, just replace in and then find the value of V, so which will end up with 7.41. Okay, where the image will be formed at the back of the lens. Okay, so if we use the magnification, okay, so we will end up with the height of the image 5.19, okay, negative 3 meter or 5.19 millimeter lah. Okay, so the characteristic of the image that we have is an, you will have a real. Okay, so from the drawing we have an inverted and diminished diagram, right? Okay, so real, inverted and diminished lah. Okay, and the image is formed at the back of the lens. Okay, so next we look into example 7.8. Okay, so example 7.8, we have a thin plano-convex lens. Okay, so plano-convex, that means you will have a convex one side and then the other side will be a flat lah. Okay, plano-convex lens. Okay, made of glass. Okay, refractive index over here is given as 1.66. Okay, when an object is set up 10 cm from the lens. Okay, so 10 cm from the lens, so this will be the object distance. Okay, and then we have a virtual image 10 times its size. Okay, so virtual image you have a 10 times of its size, so that means you have a magnified image lah over here. Okay, so they wanted to determine the focal length of the lens and then the radius of the curvature. Okay, from the information given, okay, refractive index 1.66, U is 10, and then M is 10. Okay, magnification is 10. So by using the magnification equation, okay, negative V over U, which will end up with 10. Okay, so that means V will be equivalent to negative 10 U lah. Okay, so if we replace in the thin lens formula equation, 1 over F, 1 over U plus 1 over V. Okay, just replace in the value. Okay, so U, where V will be equivalent to negative 10 U. Okay, so solving this, okay, then we have a negative sign over here because it is a virtual image lah. Okay, so solving this, we will end up with focal length which is equivalent to 11.11 cm. Okay, and then for the next part, okay, since the lens is a plano-convex lens, so therefore R2 will be infinite lah. Okay, so if let's say we have a lens over here, okay, ray traveling, so this one will be R1, okay, which will be positive, okay, convex, and then over here you have a flat surface. So when we have a flat surface, the radius will be infinite lah. Okay, so replace into let's make an equation over here. Okay, so focal length given, refractive index we have, so 1 over infinity, which will end up with 0. So therefore we can determine the radius R1, so which will end up with 7.33 centimeter. Alright, next for example 7.9, okay, which will be the last example. So this one you have a radius curvature, okay, of the faces of a thin concave meniscus, okay, concave meniscus lens, okay, where the material refractive index is given 3 over 2, and it has a radius of 20 cm and 10 cm. Okay, now they wanted to determine the focal length in air, and then when it is immersed in a water where refractive index is given is 4 over 3. Okay, alright, so over here, okay, so the refractive index of the medium, which will be N2 lah, okay, 3 over 2. Okay, so since we have a concave meniscus, okay, so the both R1 and R2 will be positive lah. Okay, so if you have a ray traveling, okay, over here, so this one will be R1, okay, positive, and over here will be R2. Okay, so both radius 1 and 2 will be positive lah. Okay, over here. Alright, so next for the equation, okay, n minus 1, okay, 1 over R1 over 1 over R2, just replace in the value where n will be equivalent to 3 over 2 lah, okay, of the medium. So once we replace in, okay, and then the final answer, we will end up with f is equivalent to negative 40. Okay, now for question B, you have an immersed in a refractive index 4 over 3. Okay, so that means you will have n1, okay, which will be equivalent to 4 over 3. So the general lens maker equation will be ratio of n2 over n1. Okay, so n2 still remains the same, 3 over 2 over from the previous one lah. Okay, so replace in. Okay, so the final answer we will end up with negative 160 centimeter. Okay, so we have done with chapter 7.